Hello friends, welcome to this session. Today we are discussing the law of velocity addition. Consider two frame of references S and S dash. They are relative to each other. Let us consider that the coordinates of particles in frame S are x, y, z, t. And for the frame of reference S dash, the coordinates are x dash, y dash, z dash, t dash. Then the components of its velocity in two frames may be written as ux is equal to dx by dt, uy is equal to dy by dt, uz is equal to dz by dt for the frame of reference S. Similarly, for the reference S dash, ux dash is equal to dx dash by dt dash, uy dash is equal to dy dash by dt dash, uz dash is equal to dz dash by dt dash. This is for the frame of reference S dash. By applying inverse Lorentz transformation, we get the x is equal to gamma into x dash plus vt dash, y is equal to y dash, z is equal to z dash, t is equal to gamma into t dash plus vx dash by c square. Then differentiate the equations. We can write dx is equal to gamma into dx dash plus v dt dash, dy is equal to dy dash, dz is equal to dz dash. dt is equal to gamma into dt dash plus v dx dash by c square. Then for the component of ux, simply we are moving along the x-axis, or we are observing the event, that the velocity addition in terms of ux propagation. So ux is equal to dx by dt is equal to gamma into dx dash plus vdt by whole divided by gamma into dt dash plus v dx dash by c square. So simply we can write ux is equal to dx dash, gamma gamma get cancelled, so dx dash plus v dt dash whole divided by dt dash plus v dx dash by c square. Then divide dt dash. So ux is equal to dx dash by dt dash plus v dt dash get cancelled. Then whole divided by 1 plus v by c square dx dash by dt dash. So we get the dx dash by dt dash is nothing but ux dash. So we can write ux is equal to ux dash plus v by 1 plus v ux dash by c square. Similarly for y, so uy is equal to dy by dt, then dy dash by gamma into dt dash plus v dx dash by c square. So again divide dt dash throughout the equation. So dy dash by dt dash is equal to gamma into in bracket 1 plus v by c square dx dash by dt dash. Here this dx by dt is ux and this one is the uy. So we can write uy is equal to uy dash plus 1 whole divided by 1 plus v ux dash by c square. Similarly for uz, again taking the dz by dt is equal to dz dash by gamma in bracket dt dash plus v dx dash by c square. So again divide dt dash throughout the equation. So we get dz dash by dt dash whole divided by gamma into 1 plus v by c square dx dash by dt dash. So for this we can write uz, for this we can write ux dash. So uz is equal to uz dash, then 1 plus vux dash by c square. So this is the relativistic law of addition of velocities. While in classical mechanics, ux is equal to ux dash plus v, uy dash is equal to uy, uz is equal to uz dash. So if v is far less than c, that is v by c is far less than 1, then this term vux dash by c square is negligible in comparison to unity. Therefore, you can write ux ux dash is equal to ux dash, ux is equal to ux dash plus v. This is shown by classical mechanics. When ux dash is nothing but the c, or v is equal to c, then what is the equation? The equation is ux is equal to ux dash plus c whole divided by 1 plus cv x dash by c square. Similarly, ui dash is equal to ui, uz dash is equal to uz. So here I am substituting the ux dash is equal to c. So the equation becomes ux is equal to x dash plus, that is the c, where you are taking the v is equal to c, then whole divided by 1 plus cvx dash by c square. So here ux is equal to c. Then if one of the object is moving with velocity that equals to that of the light c with respect to other, then the relative velocity is always equal to c, even whatever is the velocity of the other. It means one object is moving with constant velocity, that velocity equal to the speed of light c. Both are relative with each other. Then the relative velocity is always equal to the speed of light c, even whatever is the velocity of the other. So when ux dash is equal to v is equal to c, then you can write ux is equal to c. Hence the addition of the velocity of the light to the velocity of light merely reproduces the velocity of light. For that, we consider the transformation equation, Lorentz transformation equation, that the x dash is equal to gamma into x minus vt, y dash is equal to y, z dash is equal to z, and t dash is equal to gamma into t minus vx by c square. Then just taking the differentiation, that the dx dash is equal to gamma into dx minus v dt, dy dash is equal to dy, dz dash is equal to dz, dt dash is equal to gamma into dt minus v dx by c square. By substituting these values, so x is equal to dx by dt. So write the equation that equals to gamma into dx minus v dt whole divided by gamma into dt minus v dx by c square. This gives the ux dash is equal to dx by dt. So I am dividing whole side dt by throughout the equation. So dx by dt minus v dt by d. So we get the v whole divided by 1 minus v square by c square dx by dt. So here dx by dt is nothing but the ux, and here also dx by dt is the ux. So we can write ux dash is equal to ux minus v whole divided by 1 minus vux by c square. Similarly, for y component, that is the uy dash is equal to dy whole divided by gamma into dt minus v dx by c square. Just simplifying it by dividing the dt throughout the equation, so we get dy by dt whole divided by gamma into 1 minus v square by c square, v by c square dx by dt. So we get uy dash is equal to uy, so this term is uy whole divided by gamma into 1 minus vux by c square. So dx by dt is the ux. Similarly, we get uz dash is equal to uz whole divided by gamma into 1 minus vux by c square. So this is the velocity addition or the relation between the variation of velocity. So I hope you understand all these things. So thank you very much.